Okay, if you keep on holding this cursor, you can see some illustration of the sign convention of those wind load action. Okay, now we can directly define the direction like windward or leeward acting around along the positive or negative x direction and then map them with the selection type as regular, type 1 or type 2 because if there would have been two types then you could see two types listed out in this drop down list for selection, but we have defined only one type. So this way you can see only one type is selected. Okay, now imagine like the orthogonal loading is different. As I mentioned, you can have two different possibilities for wind action because of different building geometry. Might be the wind on the other direction is having a different wind intensity. So what you can do is like you can define two different types, or maybe the other orthogonal facade of the building is having the less or different exposure area. Okay, now we will define another type, but before I go ahead, just to let you know that we have defined the wind load on the positive x-axis. Now you can see that wind load is being applied in a very irregular or haphazard way. You can see that the distribution is not well defined. The reason is it has identified the bracings, it has identified every kind of irregular geometries because once there is a bracing, it is no more a square panel. So hence the distribution might not be proper as it is supposed to be a very well-defined distribution. So in this case, it is not suggested to use the regular procedure for defining the wind load if you have some integrate panel geometries. So let's see how we can refine this. Now we will go to input editor. Now here our group definition that we have defined for the wind load will come into the picture and it will going to help us to properly apply the wind load very neatly on the specified panel. This application you can't do it from graphics. You have to go to the input file and then define. Just go to this command called wind title X. Then you can see like wind load X1 then type 1. So you need to add some command like list then space then the group name of that panel that you have defined. Now here in the case I have defined like wind 1 then wind 2 wind 3. Just recall drag the video earlier you can see that we have defined three different wind group definition. Now you can see I have assigned it to the specific panel group. Now, exactly, it is being applied on those panels, ignoring all those unnecessary geometries, members like bracings and all. Now, you can see very neatly it has applied, and exactly the calculation, all those calculation from the panel area, then intensity, then again it is fragmented into the nodal load. These calculations are done correctly in this case. So you can use this group option also for applying the wind load in addition to using them for the flow load. Okay, now we will apply the wind load on the other orthogonal axis. Now here, before I define it on the other axis, let's see how we can influence the direction of the wind by using the option like factor or other option like windward or leeward. Now you can see I have used the -1, so wind is going to hit from the opposite end, but this time, it didn't find any kind of regular geometry when it is hitting from the opposite end. That's what the, graphics looks scrambled, but indeed it is calculating correctly. So let's define the wind load on the opposite side, that is on the other side in the x-axis. So just define the direction as negative. Keep it as like windward face because it's not a leeward face. Just reverse the direction. But the moment you reverse the direction, it looks very scrambled because this time it is hitting on the opposite side, and as mentioned earlier, it is just considering all those irregular geometry, including those bracings and all, and that's why the loading looks very scrambled. So the way out here is to properly organize them with the group name. So a similar way, we'll go to the input file. Here in the input file, just scroll down and go to the load case. I think it's the load case number 4. We have already defined the 3. Just see the pattern and use it for the load case number 4. So let's give like wind, I think it was 1 and 2. Okay, let's see by assigning only 1. Okay, this was the earlier one. This is the new one. Now you can see here how nicely it has applied specifically on those panels which we have instructed the program to consider. But we haven't yet defined it to the other portion apart from this opening, because opening we are not going to consider. So let's use the same procedure and use the wind as wind2 in the group name, and let's see how it's going to influence. Now you can see the top portion of the gate as well as the remaining portion of that facade are being influenced by the wind load. Now we are only left out with the slope portion. So what you can do is similar way, take the slope panels, take all the panels that the way we have done it for the flow load and define by some group name. Just exclude all those bracings. Don't use the floor because it's not a floor load. We're going to use the wind load on those slopes, not the gravity load on those slopes. So use the beam option while defining the group. Okay, so we gave some name so to this group. So we will use that group name. So we have defined the group name as Wind 4. So we are specifying the name as group 4 here. Now let's see how my wind distribution looks like in the graphics. Now here you can see it has perfectly represented the uh, those portion of the panels which is going to experience the wind load. How we have idealized, how we have considered like in the entire facade. We have considered like these two gates would not be influenced by the wind load, they would be kept as open, and the remaining portion, including the slopes, is going to be exposed to the wind load. And exactly program has delivered the wind load on those panels. So anyway, this is the way you can properly apply the wind load to the specific panels. If you want to include any members to be considered within that panel, you can exclude them in the group name, and accordingly you can perfectly instruct the program to specifically apply the wind load to that specific panels. Okay, so next what we are going to do is apply the wind load on the orthogonal direction, that is on the z directions. Before that, let's see how the wind load vectors look like. These are basically the nodal load. You can see, as I mentioned, just scale it up. You can see these are applied on the different nodes, but the calculation is based on the panel that we have considered. So if the panel identification is not proper due to those bracings, then all those calculation would be jeopardized. Okay, so as we mentioned earlier, like my wind loading on the z direction, the pattern would be a bit different, like wind intensity, I'm saying, because the building geometry on those orthogonal direction is not same as direction we consider in we have considered in the x direction. So here, assuming that wind load would be different, the geometry is different, and also the exposure is bit different considered to the other facade on the orthogonal direction. So we have to define a different intensity information by a different wind definition. So what we'll do here, we only have a one wind definition like type 1. So next we can define different type, give it a name like type 2. You can keep on defining the n number of types here. Just use the AC procedure, and if you think that okay, my wind speed is different, uh, some other parameters are different compared to the other orthogonal directions, then change those settings. And you can see the wind intensity values are also different, and assuming that the factor here is also different, assuming like 80% would be exposed, keep it as zero point 0.8 and then assign it. All the nodes should be considered. That doesn't mean that the wind is going to hit on all the nodes. These are the nodes available for the wind load to be applied. Okay, select the Z directions, select the second option, and you can add it like this, you can see. Now again, you can use the similar way to apply it on the opposite side along the same axis. So next we will use wind load minus Z. Go to the wind load and the type would be same. Give it like -1. You can see something called leeward. Leeward is something like when it is hitting from the inner face of the building. Okay, now assuming that the other side uh, is completely open, just hypothetically saying maybe it's completely open or closed, but if any of the facade is completely open and you think that okay, my entire portion of that panel would not be considered for experiencing the wind load, only my the projected portion of the members would be exposed to the wind, then you can select the open structure. Now, the moment you select on the open structure, the wind load would be only applied on the exposed portion of the member. See, you can see on those exposed portion of that member line, the wind load is applied. So just rolling it back to the closed. So we have different options as I mentioned, like windward, leeward. These are mainly very useful if you are using some fine consideration like suction force due to this Bernoulli's effect, which is hitting the roof from the inside, and due to the difference in pressure, because when the wind is blowing through the slope portion, due to this increase in the velocity of the wind, due to this aerodynamic effect, the roof is very much susceptible to get blown off. They are having immense internal pressure compared to the external pressure. So basically, due to this pressure difference, the roof would experience like the pressure is hitting portion from inside the room or inside the building. So you want to simulate this by using the leeward option. Okay, now what we'll do here is the last step for this modeling is like assigning all those bracings as tension only. Uh, what you can do here is select all those bracings, and we have already defined the section. Just assign it as as a material steel. The default was concrete, so we have changed it to steel, and then we will assign the material property here. Now, in case you find like after performing the analysis, you are getting some error message, that it's not mandatory. Sometimes it might happen, few of the assignment is not proper because we have taken the model from physical modeler. Just go to this member property and just play around in the input file. Just follow the steps. Just play around assigning the constant to the missing physical members. Okay, so this time we are also going to assign the tension only property to those bracing members. Go to the specification, select tension.